Hi folks, today I'm going to teach you how to do the 55s, which is also the Garfield worksheet. It's a new topic called Empirical and Molecular Formulas. Empirical formulas are the simplest formula, or a formula that's reduced the most it can be, and molecular formulas are the true formulas. These steps 1 through 5 are on your worksheet, but they're also found on your unit pack cover, and we're going to go through these steps as we solve the following problem. First of all, I want you to know this machine right here is called a mass spectrometer. You would inject a sample of a compound that you found, and then the mass spectrometer will analyze and give you the percents of certain elements that are found in the compound. You might see these on certain CSI shows that are on TV. So we're going to follow these instructions and solve the first problem. So in this problem it says the molar mass of nicotine, one of the most addictive drugs in the world, is 162.15 grams per mole. That number will come in very late into the problem. Nicotine was analyzed by using a mass spectrometer and found to be 74.00% carbon, 8.65% hydrogen, and 17.35% nitrogen. Find the empirical formula, the simplest formula, its molar mass, and then find the molecular formula. So here we go. The first step that we read at the top of the page and the cover of your unit pack is convert percents into grams. So I don't have 74.00% carbon. I have 74.00 grams of carbon. And I need to convert those grams into moles. That's step 2. So that's grams of carbon. So I put grams of carbon down here and convert it to moles of carbon. I go to the periodic table to get the molar mass, and it is 12.01 grams in 1 mole of carbon. I do the math on that, and I end up getting 6.162 moles of carbon. I do the exact same thing for the other elements. I don't have 8.65% hydrogen. I have 8.65 grams of hydrogen. Again, I need to convert that to moles. So grams of hydrogen there, moles of hydrogen on top. I use the molar mass off the periodic table. 0.00 grams is 1 mole. That's a quick one to solve, and I get 8.65 moles of hydrogen. I do the exact same thing for the nitrogen. I don't have 17.35% nitrogen. I have that many grams, and I convert that to moles as well. Take it right off the periodic table. 14.01 is 1 mole. I crunch the numbers on that, and I get 1.238 moles of nitrogen. Stop the video at this point in time. Take a look at that and make sure you understand all the steps that I did. Now you have a lot more room on your paper than I do on this screen, so I'm going to get rid of this information. And we're going to go on to step 3 where it says find the ratio between the elements. So these are the mole amounts that I have. So I'm going to go carbon, 6.162. And I'm going to go hydrogen, and I'm going to go 8.65. And I'm going to go nitrogen, 1.238. Now we can't have a molecule that has parts of an element in it. So we're going to have to go to the next step, which is divide by the smallest mole number. And in this case, it's 1.238. So I divide them all by the smallest mole number. 1.238, 1.238. Pause it for a second, take a look at what I did, read the step, which is step 3, and then progress from there. I do the math on this, and I get carbon at 4.977. I get hydrogen at 6.99. And I get nitrogen at 1.000. 0, following sig fig rules for all of this. Now it says in number 4, make sure the mole numbers are whole numbers. If we end up getting a number that has a 0.9 in the tens place, we're going to round up. If we have a 0.1 in the tens place, we're going to round off. If it's some other number, we might have to multiply that completely through. So if we end up getting a 0.5 in the tens place, we might have to multiply it by 2. Or if we end up getting a 0.33, we might have to multiply the whole thing by 3 to end up getting rid of it. Or if it ends in a 0.6, we might have to multiply by 3. But we look at these and we have a 0.9 there, a 0.9 there, and a 0 there. So this rounds off to carbon having 5 atoms of carbon for every 7 atoms of hydrogen and every 1 atom of nitrogen. This would be known as our empirical formula, or formula in lowest terms. Pause the video, take a look at what you see there, and we'll go on to the next step. The next step is doing the math to figure out how much C5H7N1 has for a molar mass. And when we do that, we end up getting 81.06 grams per mole. That's how much the empirical formula has for a mass. Now, when we go up into the problem, right up here, it tells us the molar mass of the molecular formula. So what we do is we take the mass of the molecular formula divided by the mass of the empirical formula, and it gives us a number. So we're going to take 162.15 grams per mole. That came right from the problem, right there. And we're going to divide that by the molar mass that we have, which is right here, 81.06 grams per mole. That's the mass of the molar mass of the empirical formula. And when we do that math, we end up getting 2.000. So what do we do with that? Well, that 2.00 means that the true formula, the molecular formula, is twice as massive, or has twice as many grams in it per mole as the empirical formula. In other words, it's telling us that we need to multiply our empirical formula by 2 to get the true formula, the molecular formula. So I would have C10, H14, N2. And that would be my molecular formula. That's how you go about doing these problems. A little word to the wise, the next 3 problems don't work out as nicely. For instance, let's say we did this math and the number ended up as a 2.3. If we multiply 2.3 right here, we end up getting some really goofy numbers. So what we might have to do is take this and say, okay, we can't multiply it by 2.3. Let's multiply this by 3. And now we get a number that's a whole number. Or let's say this said 2.5. Let's multiply this by 2, and we end up getting a whole number. Or let's say this number was, I don't know, 4.66. We could multiply that by 3 and get a whole number. So it's just a little trick to be able to figure out what the molecular formulas are. And in questions 2, 3, and 4, you will have to multiply by a 3 or a 2 or a 3 to get 2 whole numbers. Come in for help if you need it. Otherwise, that is how you do empirical and molecular formulas.